Thank you all, Theo. And my name is Tomasz Szydło. I'm co-PI of this project, Federated Edge HPC architectures. So project team, the main leader is Theo Spyridopoulos. He's sitting somewhere in the back. So I'm co-leading, and he's the project team members from Cardiff and Newcastle University. So we are working together on this project. I will remind the motivation because we have new colleagues that we haven't seen before. So our motivation and the aim of this project is to enable real-time decision-making and privacy preserving on the edge with resource-heavy computations on HPC. So our aim is to combine somehow edge computing with HPC, and I will discuss some findings that we have found and our observations. So we are trying to explore the feasibility of federating HPC with the edge. We are trying to identify the enablers and barriers. We did some, but it's still work in progress. And we are working on the roadmap, what we need to make, what actions we should undertake to make this confederation happen and be successful. In the project, we have two pillars. One is a community one, so we are talking to the stakeholders who are interested in this Edge and HPC federation, and the technology pillar, where we are trying to find the answers to the technical question, how to do it. So because it's quite difficult, and I will show you that it's plenty of things to work on. But going to some details. So we have contacted some HPC owners and the different HPC in the UK at different tiers. So tier 1. So I think that we have colleagues from the tier 1 at least in this room representatives, tier 2 and 3, some of them. But nevertheless, and of course we have a private one. One of our observations is that HPCs at tier 1 are quite flexible and are trying to modify the software stack that they are using, trying to be more cloud native, at least to some extent. And we'll discuss a bit more later. Tier 2 and tier 3, I would say that they are more legacy ones, and the private ones, it's mostly owned by companies and small entities, so they are quite flexible because they need to deliver the hardware for their needs and the products that they have. On the other hand, we have edge computing, and we had during the previous conference, previous meeting, the question regarding what edge computing is. So more or less, we all know what is edge computing, but the problem is that edge computing is not equal. It's not one single kind of device. It's not only Raspberry Pi, and we can't think it's edge computing. So in the project, we are analyzing different flavors of edge computing and different sizes. Starting with enterprise edge computing, so all of the data centers collocated within 5G close to the GSM stations might be treated as edge. Then we have hospitals, factories with the server racks. It's edge computing as well, because we have cloud computing somewhere in the US, for example, and some hospitals in different countries, different cities. So it's edge computing as well, but the industry and in the factories. And finally, we have edge computing as embedded devices. All of the smart cameras, voice assistant in the home, and so on and so forth, smart gateways that we have in the homes, it's edge computing as well. And now the question is, what are the benefits of combining edge computing of different sizes with HPCs at different places in the country? So we are trying to find some answers to all of the edge computing sizes and the flavors that we are seeing here. After having some, I will describe some outcome of our meetings and the workshops that we had. But we tried to summarize our findings and observations on one slide. This is what we come up with. It's work in progress, so some details will change, I believe, in the final version. But what is quite important, we are seeing and we are now HPCs for quite a long time. It started with mainframes, with Cray machines, then we had supercomputers and so on and so forth. And for most of the time, it was for title-coupled services where we wanted to have huge number, hundreds of thousands cores, MPI processing, message passing interfaces between the cores, just to run the heavy simulations in the HPCs. This is what we know for a long time, HPCs. Then we have seen the SLAM for job queuing system, management, and giving access to the system to researchers and so on. But then, because there were different let's say, business incentives, we have seen the cloud computing, which is completely different idea with this elasticity, providing services on demand, providing services to the clients, paying only for the used resources, and so on and so forth. And in the meantime, we have seen the advent of edge computing. So we know edge computing because it was some sort of extension of the cloud, moving some computations from cloud to the edge to make local processing, enabling real-time operations, and to decrease the usage of the cloud computing. So we know how to deal with the edge with a combination of the clouds. That's why we have term we are using in the papers, edge cloud continuum, because we are treating as a single continuum. And now, where is the problem? The problem is that HPCs are changing a little bit. They're moving from this Slurm-based software stack towards cloud native slowly. Of course, the starting point of this change might be a bit different. Most likely it's because of some SMEs incentives and the request to have access to the sovereign AI, not paying US companies for using HPCs. So we think that this is we can think of a starting point as the sovereign AI in this discussion, AI factories in Europe and so on and so forth, as a triggering point for this dual stack software, software stack in the HPCs. And now the problem is that we know how to do edge cloud continuum, so we can just take our knowledge and experience and we can move towards edge HPC, but in the cloud native stack. But there is a huge gap in the research how to deal with edge computing, which is quite mature, with the legacy HPC stack. So how to utilize the real-time operations on the edge with the heavy computations on the HPC. And this is what we would like to combine in this project, how to deal with this edge HPC cloud-based stack and legacy HPC stack. Of course, this figure will change a little bit, I think, because it's the first draft. They come up after a couple of discussions with the different stakeholders and so on. Nevertheless, this is the direction in which we are going. And now activities. I will discuss the workshop meetings that we had and the roadmap on which we are working now. So I will give you some glimpse of some current work. So during the workshop, we had one workshop. It was today's. First one was regarding the system, second one, the applications. We had some people attendees, so we have discussed with them and we have identified barriers and enablers for this Edge HPC Federation. But we also had some keynote speakers, which is quite important, on the system during the first day. Regarding the systems, we had Paul Graham from NVIDIA, so we had some idea what is the NVIDIA plan for what they are thinking about the AI factories and what kind of a software stack they are planning in the AI factories, because we need to know that AI factories in EU are mostly based on the HPCs. So they need to convert HPCs to the AI factories, cloud-based stack. So it's quite interesting. And we had the colleagues from Spain that are working closely with Barcelona Supercomputing Center, and they are advocating for dual stack in the HPC entities for many AI factories. So we are trying to collaborate with them because we have some view and a point of view from EU and what happens with AI factories. And we have seen AI antennas as well during the previous year of HPC meeting. Regarding day 2, we had the colleagues from Italy. They're working on the TIMA project, and this project is about dealing with natural disaster management, where they have simulations on the HPC for predicting the consequences of some disasters, but they're feeding these models with the data collected by the drones in real time. So this is what exactly we are looking for in this kind of workflows. We had Nick Lane from Flower Labs, because it's still unknown how to use federated learning, because it's natural, workflow for this Edge HPC direction. But the problem is that if you are looking for HPC on the Flower Labs, you will not find the details because it's something unknown yet. So this is something that needs to be discussed. And we had Omer Rana from Cardiff University, who talked about the transport problems in this case. And we had our colleague from University of Hull. She is a part of the UK National Edge AI Hub and regarding some problems of edge computing and the models. Regarding the margins, I will try to be very fast. So nevertheless, most of HPCs that we have spoken to are based on SLARM. So we need this more cloud-native stack, but it was discussion yesterday even with Eisenbart that we're going towards this direction, so it's done. The second problem is most of access, identity management and access to the resources now is bind to the users, not to the processes or services. So the discussion yesterday of tokens, providing the tokens might be a solution to it, because we can put the tokens to the processes and have these tokens going through the workflow. And the issue is with the different software stack and the HPC. So we can't take the software from one HPC and deploy on the other one, which we should have for the federation, but it was discussed in the other projects as well. And regarding the virtualization, we think that virtualization is quite important because we have elasticity. We would like to see containers to deploy the models and component of the system, and the identity federation unified for the processes. I'm not going to discuss more of, just briefly, we have transport scenario. In the project, we are also developing some high-level synthetic workflows on the process level. So I will discuss only this one. So we have smart cameras. We are working with Urban Observatory at Newcastle. We have data and video from the cameras deployed in the cities. So we are counting the number of cars. But on the HPC side, we have network traffic simulation. So we are feeding the data from the cameras to the Sumo simulator, and we are running it on the HPC. But the workflow is, idea is to present, describe this workflow on the high level, just as some sort of a benchmark. And then we'll try to deploy it using different technology stacks. And we'll try to compare what are the pros and cons of different ones. And we have healthcare scenario with federated learning. So if you would like to know some more details, please ask Theo. He's sitting in the back. And regarding the paper and the roadmap, we are collaborating with the colleagues from Spain. So European point of view, EU point of view on this Euro HPC. But we also have a contact with a team working on the Pegasus workflow, scientific workflow execution engine from US. It's a Dillman team, and we are trying to, we have finished in the initial phase of discussion. We are trying to involve them to give us, to have their point of view on this HPC federation, because what is quite interesting, in the US, they are working on a similar type of a federation Edge HPC. So this is what we are high hopes for this collaboration with them. And as the next steps, so as we have discussed, we'll have one more workshop at Cardiff, and we are developing some workflows and trying to work on the paper. So I will inform all of you. And of course, if you have any questions, you'd like to know something more, we are here till the end of the day. Thank you.